Okay, we left off yesterday. I was trying to get through these graphs and we didn't. So let's get through those graphs really quickly. We've got a few more textbook problems. We got a couple word problems, and then I want to start looking at graphs. So when I did this with Alpha, we actually graphed these in the calculator. So go ahead and pull your calculator out. I know we got to 37, and then I think the end of the last zoom is where my calculator decided it was done. So I hope that does not happen today. But we are going to graph these little equations and see which of their right sides look most like these, A through H. So just a reminder, while you guys get your calculators out, I'll do the one that's already done. We did -2/3x to the fourth. That looked like a downward facing parabola, so we said that was most like G. So that's why for 37, I have written G. And then I tried to get one more in and it didn't let me. So now we're gonna just keep going down that. I know it says 39 next. I'm just gonna go down the page like that. I'm gonna do 2x raised to the 1 over 1 divided by 4. Why are you not right? 2x raised 1 divided by 4. All right, that's a fraction exponent. And so I graph that. What graph does that look like? A square root. It looks like a radical function. So which one of these, A through H, does this look like? A, F, D. Let's use D. Perfect. All right, awesome. We're going to keep rolling. If you can't type this fast, just watch. But I really encourage you to learn how your calculator works. Ooh, make sure that's a negative. Next, I'm going to do -2x to the -2nd. We have a negative exponent. That's like our reciprocal graph, but it's a little bit funny because I've got two downward ones. Which graph does this look like on our picture? H. Most looks like H. I know it doesn't have the left-hand side, but we assume it looks something mirrored like that. All right, I'm going to jump over to 38, and it says 1/2 x to the -5th. Since it says 1/2 x to the -5th, I'm going to assume it's kind of like the last one with that negative exponent. Make sure you get negative in there. All right, very cool. What does that look like? Letter A. Awesome. Now I've got -x to the 5/3. That's kind of a funky graph. I think we said, I know it might be confusing between G and F, and we did already use G. I think when you zoom in, it does have like a tiny bit of a curve, but then it mostly goes out straight. So I think we last class said F. F was a good bet there. It's a little bit more wide than G goes. G goes more straight down, F goes a little bit wider. And then very last one, I've got 1.7x to the 2 divided by 3. Bless you. And this one's kind of similar to the one we just looked at. It almost looks like it's a radical, but it's a little bit more like kind of straight line-ing than the radical one. So I think we called this C last class. Ooh, didn't we do this? F and C. So I know we just sped through those, but that was just graphing and looking at different equations and kind of seeing how they relate to each other. We okay with that so far? Okay. The next part I'm going to go through pretty quickly as well. This is not as important as some of the other stuff that we're going to get to today. That's why I'm moving a little bit faster through it. This says determine whether, and I don't need my calculator anymore, determine whether the function is a power function. Okay, time out. What is a power function? Just maybe one page back. Y equals K times x to the power of A. So we have x and we have an exponent with our x. That exponent component can be positive, it can be negative, it can be a decimal, it can be a fraction, it can be any of those things. Now, one thing I do want to note here, it says given C, G, K, and pi all represent constants. So if we see C, G, K, or pi, we're going to say those are constants. So it's like 5 or like 1/2. So in all of these, I want us to say yes or no, it's a power function. And if it is, I want us to state the power and the constant. Okay, so looking at number 1 and my example, is that a power function? Yes or no? Yes. What's my power? 5. Good. It's power of 5. And then what's my constant? What'd you say, Eva? What'd you say before? Negative 1/2. Good. Negative 1/2. Good. That was easy because I've got x as my variable. I know the next one says 3. I'm just going to keep going down the page. What is number 3? Is that a yes or a no? What'd you say, Ryan? Did you say something? Oh, someone said something. Quinn? No. Why? I don't believe that. Why is this a no? How is this different than the one we just looked at? X is the exponent, and that's a problem. I need x to be the variable with an exponent. I don't want x to be the exponent. All right, what about the next one? Number 2. Yep. What's my power? 5/3. What's my constant? 9. Very good. All right, now I'm going to do number 4. This is kind of a tricky one. I'm going to say it's yes. I'm going to help you out there. It's yes. What's the power here? Not 1. 0. If I don't have an x there, technically anything raised to the 0 power is 1, but the exponent of 1 means that there would have to be an x there. There's no x there, so it's an x power of 0. So I'm going to say yes, and I'm going to say p equals 0. And what's my constant? 13. Very good. You guys are killing this. Good job. All right, let's look at the next couple. All right, what's going on with number 5? Let's team time out, though, for a second. It said my constants are C, G, K, and pi. So C is not my variable. C is my constant. What letter is the variable then this time? M. What's the power of M? 0. Not 0. 1. When you physically see it, it's 1. When you don't see it, it's 0. So I'm going to say this one's a yes, and it has the power of 1, and its constant is C squared. A constant's just a number. It could be 3 squared every time. It's kind of a funny way of writing it, but it's still a constant. Similarly, what about number 7? Yes or no? Yeah. What's the power here? Which one's the variable that I care about? G's a constant. So it's T. What's my power? 2. Good. What's my constant? And 1/2 and G, both of them together. All right, what about number 9? Yay or nay? I think it's okay. It's okay. Which one's the variable with the exponent? D. Good. So my power is 2, and then my constant is just K. Oh, my power is not 2, it's -2. This is in the denominator. Sorry, Alpha, I didn't do that right today. -2. I'm going to make it a little bit cleaner. -2 in the denominator. All right, I've got 3 more just like this. What about number 6? What's the variable? What's the variable with the exponent? V. V is not a constant, right? That wasn't one of the letters they gave us as a constant, is it? Nope. So then Is this power function? Yeah, what's my power? Good, and what's my constant? 1/2 k, good. What about letter number 8? What's my variable with the exponent? R. Good, so is that a power function? Yeah. R has the power of what? Good, and what's my constant? 4/3 pi, very good. And the last one's a little confusing because it doesn't, M or A are not represented as constants. I'm going to say that M is a constant, so A is my variable. If A is my variable, what's the power of A? If A is my variable, what's the power of A? 1. And what would my constant be? Yeah. So that one's another yes. This is not the most important thing that we're going to do. We have to flip back. There's 2 more word problems that I have to get through today. Why this class has felt so short. We will not hit 2, 3, but we will finish this section. So go back to your notes if you were away from them like me. I'm going to do the last 2 things are word problems. So number 4 and 5 are word problems. And they're using the directly or the inversely related ideas. The volume of a gas varies inversely as the pressure. Okay, we're going to stop and make an equation. My normal equation for varies inversely is y equals k over x. In this problem, we don't have a k. So I'm going to have to find k. Is volume your x or your y? Y. And then that makes pressure my x. So I'm going to use these numbers as an example to find my K, and then I'll use the last number to actually find the volume. So volume is 9.2 when pressure is 163. In that case, I'm just going to plug in. Volume is 9.2, pressure is 163. So I've got 9.2 equals K over 163. How do I get K by itself? Multiply by 163. I think last class we got 1,499.6. Yeah. Perfect. That is helpful to me because now I only need to be given either pressure or volume, and I have my constant 1,499.6, and I can find the missing piece. The last sentence tells me what I want to find. It says find the volume when pressure is 74.1. Where do I put 74.1 in my equation? For P on the bottom. And then I'm trying to find V. So we're just going to do 1,499.6 divided by 74.1. And did we get 20.24 last class? Yeah. Perfect. If that's a little funny, I want to do one more like that with you guys, okay? I know I'm rushing, but here we go. Last problem. It says the weight of a football player varies directly as his shoe size. Okay, varies directly is y equals kx. Which one is my y? Weight or shoe size? Weight. And then my x is the shoe size. I'm just going to use x because I don't like using s as a variable. We're going to use Joe as an example. We'll put 182 in for my weight. We'll put 11.5 in for my x, and we'll find k. So we're going to do 182 divided by 11.5, and we're going to get, what'd you say? Good, 15.83. And so now if I want to know if John has a size 13 foot, how much does he weigh? Where do I put this 13 at? And for the x, good. So I'm going to say his weight is equal to 15.83 times 13. And what did you get, Ava? 205.7 is good.
205.7. Okay. I had to get through that because you have that due next class. Okay. We'll hit 2-3 tomorrow. All right. Thanks, guys.